Happy morning, students. Welcome to Vishwas Higher Secondary School online classes. So, last class we have discussed about early concept of classification of elements. The first one is Chauvet triads. The second one is Newland's law of actions. The third one is mentally periodic tables. So, Chauvet triads is proposed to John Wolfgang Chauvet. He arranged the elements in the in ascending order of the atomic masses. So tri means three. The first element and the third element arithmetic mean is equal to the middle element. This law is called Chauvet's law of triads. Some of the limitations in the Chauvet's triads. So only three triad groups are arranged in this triads. The next one is a very low and high atomic mass of the elements is not suitable for this method. The next one is Newton's law of actives. Act means 8. The first element and the eighth element is similar properties. So this arranged in the such manners. But through the Carnatic music, Sarigama Pada means the first and last one is Sasa is similar to the same manner for the this law. So this law, some of the limitations of we learned about what are the only 56 elements are arranged in the law, and the instance of two elements fitted to the same thing. So there are some limitations of we learned about. The next one is a Mendeleev's periodic tables. This Mendeleev periodic table, Dmitry Mendeleev, he is a Russian chemist. 1869, he proposed the law of periodicities. The physical and chemical properties of elements are the periodic functions of their atomic masses. He arranged only the 56 elements in the periodic tables. Some of the features of the Mendeleev periodic table last class we discussed. So vertical columns are called groups. There are the Mendeleev periodic table have a 8 groups. The horizontal rows called period. The Mendeleev periodic table 7 periods are there. So each group has divided into two subgroups, that is A and B. The similar properties of the elements are appearing in the group A and B. So he identified the one element, that is germanium. This is he proved that actual property and he proved prediction is correct. So this germanium is fitted to the Mendeleev periodic table. So today we are going to see about modern periodic table. So today we are see about modern periodic table. This periodic table proposed by Henry Moseley. Henry Moseley. In 1913. So he proposed the properties of elements arranged in the atomic number. So the elements is arranged in the atomic number. Not for the atomic masses. The Chauvet, Newlands and Mendeleev. All of you say that the elements are arranged in the atomic masses. But the Henry mostly say that the elements are arranged in the increasing order of the atomic number. Atomic number means that the number of protons and the number of electrons. Already we have discussed about atomic structure unit. What is atomic number, isotopes, isotones, electronic configuration. We have all of you discussed about in the atomic structure. Any doubt, you have to go to the video and clarify the doubt. So, atomic number means that number of number of protons or number of electrons. So, not only depends on the number of protons, also depends on the number of electrons, that is atomic number. So, in this modern periodic table, the elements are arranged in the increasing order of the atomic number, not in the not atomic masses. So, the Henry Moseley stated the law, periodic law. This law states that the chemical and physical properties of elements are periodic functions of their atomic numbers. So, the elements are arranged in the physical and the chemical properties. So, the physical and the chemical properties are arranged in the atomic number. This is the law is proposed by the Henry Moseley. So, some of the features of the periodic table. This modern periodic table is like similar to the Mendeleev periodic table. The Mendeleev periodic table is short, but modern periodic table is a long form of periodic table. So, modern periodic table is a long form of periodic table. So, we will write in the observation note the modern periodic law and who was proposed by the modern periodic law. That is, we will write in 1913 to atomic number. That is still atomic number. So we will write observation note. Who was proposed modern periodic table? Henry Moseley. He arranged the what? He arranged the elements in the order of atomic mass or atomic number. He arranged the elements in the increasing order of the atomic number, not only for the not for the atomic mass. So he stated the periodic law, that is the chemical and physical properties of elements are periodic functions of their atomic numbers. Now let us see about the features of modern periodic tables. Also we have discussed all the elements are arranged in the increasing order of their atomic number. That is the first feature of the modern periodic tables. The next one is also we have seen about Mendeleev periodic table. What is the Mendeleev periodic table? There are vertical columns called groups. Same for the modern periodic table. The vertical column called groups. That is, this is the modern periodic table. We have you have seen in the introduction class in the periodic table. So, helium, lithium, to francium. This is the group 1. Next, the beryllium, magnesium to radium. This is the group 2. This is the vertical columns. These are called groups. There are 18 groups are in the modern periodic table, but the mentally periodic table are only which what groups? 8 groups. Okay, the mentally periodic table is 8 groups, but the modern periodic table has a 18 groups. The modern periodic table has a 18 groups. Vertical columns. Vertical columns called groups. There are 18 groups in the modern periodic table. The next one is the horizontal rows are called periods. Horizontal rows called periods. So there are 7 periods. 7 periods in the periodic modern periodic table. But the same 7 periods in the what? Mental periodic tables. So modern periodic table 18 groups and 7 periods. The horizontal rows. In the modern periodic table, this is the modern periodic table. The horizontal rows that is called this is a horizontal rows that is potassium to krypton that is called periods. So hydrogen to francium, this is the vertical column called groups, and this is the periods. Potassium to krypton, rubidium to xenon, this is the periods. The next feature of a modern periodic table is the elements are arranged in the periods. This depends on the number of shells in their atoms. Already we know that what are the shells. We have discussed about the unit 11 atomic structures. There are 4 shells, that is K, L, M, N shells. It is further divided into subshells, that is S, P, D, F. This is the subshell of the shells. This is the one of the feature of the modern periodic tables. So the elements are arranged in the physical and the chemical properties. It is grouped into 18 groups. These 18 groups are named by the various family. One by one we have discussed. So group 1, that is group 1 name is alkaline metals. Group 1 name is alkaline metals, that is hydrogen to francium. This group name is alkaline metals. The next one is group 2, alkaline earth metals. எல்லாருக்குமே தெரியும், இப்போ உங்களை ஒருத்தவங்க கூப்பிடுறாங்கன்னா என்ன பண்ணுவாங்க, உங்க நேம் சொல்லி கூப்பிடுவாங்க. கரெக்டா, அதுதான் நம்ம என்ன பண்ணிருக்கோம், நேம் வச்சிருக்கோம். சில பேர்லாம் பாத்தீங்கன்னா இந்த ஃபேமிலி அப்படின்னு சொல்லிட்டு காமிக்கிறதுக்காக அவங்க ஃபேமிலி மெம்பர்ஸ் இருக்கிறவங்க எல்லாருக்குமே என்ன பண்ணிருப்பாங்க, ஆஃப்டர் தி நேம் அவங்க நேமுக்கு பின்னாடி என்ன இருக்கும், ஒரு ஃபேமிலி நேம் இருக்கும். அதே மாதிரிதான் இந்த பீரியாடிக் டேபிளுக்கு என்ன இருக்கு, ஒரு ஃபேமிலி நேம்ஸ் இருக்கு. அது குரூப் வைஸ் என்னென்ன ஃபேமிலி இருக்கு அப்படின்னு சொல்லிட்டு சொல்லியிருக்காங்க. அது எதை பேஸ் பண்ணி இருக்குன்னா, இந்த எலமெண்டோட பிசிக்கல் அண்ட் கெமிக்கல் ப்ராப்பர்ட்டிஸை டிபெண்ட்ஸ் பண்ணி அதை பொறுத்துதான் இந்த மீன்ஸ் எல்லாமே வச்சிருக்காங்க. ஓகேவா? தி ஃபர்ஸ்ட் குரூப் ஹைட்ரஜன் to francium, that is alkali metals. Next one is group 2, that is called alkaline earth metals, that is beryllium to radium, that beryllium to radium, that is called alkaline earth metal. The next one is 3 to 12, 3 to 12, that is called transition metals, that is group 3 to 12, that is scandium to copernicium. So this is the transition metals. The group 13 is called boron family. Group 14 is carbon family. Group 15 is nitrogen family. Group 16 is oxygen family or chalcogen families. Next group 17 is called halogens. Group 18 is called noble gases. Why the group 1 is alkali metals? These metals, that is except hydrogens, these metals are react with water to form a solutions. These solutions, to check the litmus papers, these solutions change to color red to blue. So these solutions are highly alkaline or basic. So it is called alkali metals. What is this? Group 1 metals except hydrogens react to water to form solutions. So these solutions we have checked to litmus paper. Correct changes red to blue. So this is called alkali metals. The next one is alkaline earth metals. The group 2 elements, that is beryllium to radium. These elements are coming to oxygen to form oxides. This oxide produce alkaline solutions. So they are dissolved in water. So these oxides are called early stages earth. So it is called alkaline earth metals. 3 to 12 groups are called transition metals because metal and non-metal, these groups are intermediate to the metal to non-metals groups. So this is called transition metal. Next one is the 13th. The first column is boron. So this is called boron family. Already we have told that what is that? We have a family name and we have a name because all of you call the name and identify the person. So we have a names. Same for the in the periodic table. So the group 13 is called boron family because that is in the top. Next one is group 14 is carbon family. Same reason for the carbon family because the first one is carbon family. The next one is 15 nitrogen family. Same reason, boron family, carbon family, nitrogen family, everyone, all of the same reason for the called the family. Okay, so these are the features of the modern periodic table. The elements are arranged in the increasing order of the atomic number. The unstandard rows are called the periods. There are 7 periods in the modern periodic table. There are 7 periods in the modern periodic tables. The vertical columns called groups. There are 18 groups in the modern periodic tables. The elements are arranged in the periods based on the number of cells. Okay. The physical and chemical properties of elements. They are grouped into various families, that is alkaline metals, alkaline earth metals, transition metals, etc. So next we have discussed about classification of elements into blocks. Already we have already told that there are elements are arranged in the periods depends on the shells K, L, M, N. These shells are divided into subshells, that is S, P, D, F. So now we have discussed about X block elements, D, D block elements, and F block elements. One by one, we will see. Okay. So all of you know that the atomic number is called the number of protons and the number of electrons. The electrons revolve around the nucleus. Already we have discussed about in the atomic structure unit. Any doubt, you will see the video and clarify the doubt. So electrons are revolved around the nucleus. So the atomic number are depends on the number of protons and electrons. These electrons are present in the shells. So these shells are further divided into subshells, that is S, P, D, and F blocks. So the elements are arranged in the what is this arrangement of electrons. So how to arrange in the shells and subshells. So now see about X block elements. So the group 1 and group 2 elements are present in the X block elements. So this is called representative elements. Group 1 and group 2 elements are called representative elements. The group 1 elements, that is hydrogen 2, francium. These elements are called metals except hydrogen. That is, hydrogen is noble gases. So, lithium to francium and beryllium to radium. These are the metals. So, first the group 1 metals. Already we have discussed about group 1 metals are called what? Alkali metals. The family name is alkali metals. Why? The group 1 metals or react to water to form these solutions. To check these solutions, litmus paper, the color change. What is this? Red to blue. So these solutions are what is this? Highly alkaline or basics. So it is called alkaline metals. So same for the alkaline earth metals. The group 2 elements are also called what is this metals. So the group 2 metals, that is beryllium to radium. This is combined with the oxygens. What is this? The group 2 elements combined with oxygen to form oxides. So early stage it is called earth. So these oxides produce an alkaline solutions dissolved in water. So it is called alkaline earth metals. So these are the X block elements. What is this? The group 1 and the group 2 elements, that is metals are called present in the X block elements. So next one is P block elements. What is this? P block elements. So the groups 13 to 18 group elements are present in the B block elements. The B block elements are variety of elements because these B block elements inside metals and non-metals and metalloids are included. That all variety of metals are present. We have taken in the group 1 that is present in the only metals. Group 2 that is present in only metals, and group 18 so that is present in the non-metals, that is F block elements. F block elements only present in what is this metals, but the B block elements inside metals, non-metals and metalloids. What is the metals and metals, metalloids? After that classes we have discussed about. Okay, next class we have discussed metals, non-metals and metalloids. So B block elements is group 13 to 18. That is B block elements is present. This is the big variety of block element because variety types of elements is present, that is metal, non-metals and metalloids. The next one is D block elements. It includes that group 3 to 12. This is the center part of the modern periodic tables. These groups are these elements are intermediate to the metal to non-metals. So these elements are called transition elements. Why this is called transition elements? Because this is intermediate to that of the S and B block or metal and non-metals. So these metals are intermediate to the S and B block elements are what is this metal and non-metals. So this is called what is this transition elements. The next one is F block elements. This F block elements includes that 14 elements, that is lanthanides and actinides. These lanthanides and actinides is present in the bottom of the modern periodic tables. So this is called inner transition metals elements. Sorry, inner transition elements. You see in the modern periodic table. So bottom of the but the number is present in the center of the modern periodic table 57 to 71 and 89 to 103. So present in the center of the modern periodic table. But this is long to modern periodic table. So this is present in the bottom of the modern periodic table. So this is called inner transition metal elements. Why it is called inner transition metals? It is placed at the bottom of the periodic tables. Okay, so this is called the S block elements, B block elements, D block elements, and F block elements. So this is the modern periodic table. So today what we discussed about modern periodic table. What is that? The modern periodic table is proposed that Henry Moseley he arranges the elements in the increasing order of the atomic number, not that atomic mass, but the three members. What are it? Chaubernis, Newlands, and Mendeleev are arranging the elements in the atomic mass, but the Henry Moseley is arranging the elements in the increasing order of the atomic number. So, what are the features of the modern periodic table we have discussed about, and the classification of elements into blocks, that is S, P, D, F block elements we have discussed about. All of you note that in the class your observation note and write in the class work note. Okay, thank you. Any doubt? Ask me. Thank you, student.